Hello aspirant, this question is from GATE 2020 Mechanical Engineering Paper Set 2, question number 31. A helical spring has constant K. If the wire diameter, spring diameter and the number of coils are doubled, then the spring constant of the new spring becomes option A K by 2, B K, option C 8K and option D 16 times K. Let's see how spring constant is calculated. So spring constant K is given as force on the spring per unit its deflection. And after using the partial differential of energy taken with respect to the force itself will give us value of K to be G d to the power 4 divided by 8 d cube N. So we can see that spring constant K is independent of force, as it is the property of, first thing, shear modulus of material G, second, the coil diameter capital D, third, the coil wire diameter small d, both are different, and fourth one, number of turns in the spring. Now let's assign the parameters for the old spring with spring constant K as small d, capital D, G and N. And for the new one, we will assign Kn, spring constant is Kn, diameter of the coil wire Dn, diameter of coil capital Dn, shear modulus remains the same, that is not changed. But number of turns have changed and they have become the new number of turns, that is 2 times the old. So let's write the relation with the old ones. Wire diameter has been doubled. So we can write 2 times D. Coil diameter has also been doubled. So 2 times capital D. Shear modulus remains the same. So we write equal to G itself. And number of turns have also doubled. So we write 2 times N. Now using this formula, the old spring constant is nothing but the formula itself, because we have taken small d, capital D and small n as it is. But for the new ones, let's see what the spring constant calculates to. Hence we have Kn is equal to G into 2D whole raised to 4 divided by 8, and this capital D also becomes 2 times capital D whole cube into 2 times N, which is equal to, now let's keep this GD raised to 4 upon 8 capital D cube N separately and see what number comes out to be the coefficient. 2 to the power 4 is 16 divided by, we have 8 will keep here and 2 cube is again 8. So let's just write that into 2. And this capital D cube N we will write here. So as said, we have separated out this K value. And what we get is the coefficient attached with this value is 16 upon 16, which is nothing but 1 times. So actually the wire diameter, coil diameter and number of turns are all doubled, and resulting from the formula we see that spring constant does not change in this case. Hence our answer here is option B, that is K. To study about springs in detail, you can refer to the NPTEL video lecture 39 Springs 1 from the course lecture series on strength of materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.